Hello, my name's Edwin. I'm a second year CS student, and I am interested in becoming a ULA for winter 2023. I use he, him pronouns, and the top two courses that I am interested in are CS 16 and CS 24. I'm interested in becoming a ULA because I find that learning assistants have been really helpful in helping my understanding in courses that I've taken, such as CS16 and currently CS64. And so today I'll explain the technical concept of something we learned in CS16, which is converting hexadecimal to binary. So let me quickly screen share. There we go. And so the example that I have here is a hexadecimal of A3F7. And we're going to be trying to convert this to a binary form. And so what's really cool is that each digit of hexadecimal corresponds to 4 bits. And that's really cool because that means each hexadecimal digit can be represented with 4 digits of binary, since each digit of binary is 1 bit. So let's get started. So the letter A in hexadecimal, well, we use the letter A because it represents a number that's greater than 9. So it goes from hexadecimal goes from 1 all the way through 9. And then when we get to 10, well, we can't write 10 because that's that's 2 digits, and that's too much. So we use A instead. So A it represents 10. And then B, 11, C, 12, D with 13, E with 14, and finally F with 15. And so, as you can see, we have the letter A, so that would be 10 in decimal. So let's write that down. And next up, we have 3, which is simply 3 in decimal. And now we look at F, which is 15. And finally, 7, so that would be a 7. Great, so now we have the decimal form of this hexadecimal that we have above here. So next, okay, so we did this step. Now we can translate that to binary. So the number 10, so let's put out 4. 4, 1, 2, 3, 4. 4 bits for each digit of binary. And so we have 10, 10. So 10, 10, 10 would be represented with 8 plus 2, if you're talking about the powers of 2. So let's see, 8 would go here, and then 2 would go here. That's because 2 to the third, 2 to the second, 2 to the first, and 2 to the 0. Similarly, so this is 8 plus 2, which is 10. And for 3, that would be 2 plus 1. So let's see, something like this, since this one is 2 to the first, and this is 2 to 0. Okay, and then 15. Well, 15 is actually a really cool one because it's all ones. This would be 8 plus 4 plus 2 plus 1. And that would be equal to 15. And finally, 7. Let's see, 7 would be 4 plus 2 plus 1. So 4 here, 2, 1. And this would be 0. And there we go. Let me just write this out. 2 to the second, 2 to the first, and 2 to 0, which would equal to, whoops, not 8, 7. There we go. And so that's how you convert hexadecimal to binary.